Good afternoon. So I'm here again. Today we are going to mathematics. So we are not going to statistics today. So what is the topic that I want to look at in mathematics for today? So we want to look at this topic called matrix. So matrix. We want to look at matrix. So what are the things we want to look at under this topic? We are going to look at definition of a matrix. So after that, we are going to look at terms or definition of terms. Definition of terms. That is the terms that are related to matrix. So we are going to look at it. And again, we are going to look at the types of a matrix. So we look at operations in a matrix. So these are some of the things that we are going to consider in our today's topic. So let's look at the first one. So let's look at this one after the other. Definition of matrix. What is a matrix? A matrix is the array of elements or numbers in a rectangular form. Matrix. Matrix. This is the array, or this is the rectangular array of numbers or elements. So the rectangular array of numbers or elements is known as a matrix. E.g., so let's say you have a 2, 4, 3, 1. So this is an example of matrix. So this is the rectangular form of it. That is, it's in form of rectangle, like when you look at the shape. So when you arrange number like this, we call it a matrix. So that's the definition of matrix. Next thing we want to look at now is definition of terms. What are the terms that we want to look at here? We are going to look at a row. Row. What is a row? So a row is the horizontal list of numbers. A row is the horizontal list of numbers or elements. So what are we saying here? Let's say you have a 1, 4, A. All these are elements, and you have it like this in a row form like this. Then we call this row. We also have a column. We have column. So a column is a vertical lists of numbers or elements. So if you have this as an example, 2, 4, 3. So this is vertical, this is horizontal. So the one of horizontal is row and the one of vertical is column. That is, don't forget, it's always in a rectangular form. So this is rectangular form. That is what we mean by row and column. The next thing we want to look at is order. Order of matrices. So let's look at order of matrices. This is n by n form of matrix. That is, when you are multiplying or you are considering the number of rows with the number of columns in forms of multiplication, but not multiplication really. So you are considering the number of rows and the number of columns. Then you call it order of matrices. Like, let's say you have this, e.g., if you have a 4, 3, 1, 2. So this type of matrix, we discover that this matrix has 2 rows. We can call this row 1 and another row. We call this row 2. So it has 2 rows. And for the columns, it has this and this. So this one is column 1 and this one is column 2. So this type of matrix has 2 rows and 2 columns. So if you want to name the order of matrix, you mention the number of rows followed by number of columns. That is, this matrix has 2 rows and 2 columns. So we call this 2 by 2 matrix. You can also have this 4, 3, 2, A1, A2, A3. So this matrix now has 1, 2, 3. It has 3 rows. By how many columns? It has 2 columns by 2. So the order of this matrix is 3 by 2 matrix. It's just as if you are taking the length and breadth of a rectangle. So here you are considering the height and the length, the vertical and the horizontal. So you are considering the horizontal and the vertical. So you can also have this 4, 5, A, B, 2, 4, A, M, N, 2, 3, 5. All these are elements. So the order of this matrix will be, when you count it, we have one row. This row 1, row 1. Also have a row 2. We also have a row 3. So it has 3 rows. It's going to be 3 by, then the number of column. We have column 1. We have column 2. This is C1, C2. We have a C3. We have a C4. So 1, 2, 3, 4. This is 3 by 4 matrix. That's the order of this matrix. So when you are considering the n time and the m time of the rows, you can also have this. If you have this, let's say A11, we call this A12, A13, to the last one, A1n. So we are taking 1, 2, 3, the n time of it, that's n. So this one will be A21, A22, A23 to A2n. So if you have A31, A32, A33 to A3n. So if you continue like that, this will stop at A. So since we consider this to be n, 1 to n, so this one 1 to, let's call this M1, A, M2, A, M3, and to the last one, A, M, N. So this type of matrix is n by m matrix. So it's n by n matrix. Oh, sorry, it's m by n matrix. That is, it has number of rows of m and number of column of n. So these are what you call order of matrix. The next thing we want to look at now, so this is gone. We want to look at type of matrix. Types of matrix. So we are going to look at different types of matrix. Types of matrix. So we have different types of matrix, but let's just take some. We have number 1. We have a row matrix. Row matrix. As the name implies, we said row already is the least number in horizontal form. So a row matrix is a matrix that has only one row. A matrix that has only one row. Or okay, let's stop it here. Only one row. E.g., let's say you have a matrix 4, 3, 1. So we have one row. This matrix has only one row. So this is the row. R1. But here we have column 1, column 2, column 3. So this type of matrix, we call this one 1 by 1 to 3, 3 matrix. So any matrix with only one row is a row matrix. We can also say a row matrix is a matrix of order 1 by n matrix. A matrix of order 1 by n. So n here it depends on the number of column that we have. So like this, our n is 3. So that is why we have this. So this is what we call row matrix. Another definition we want to look at is a column matrix. Column matrix. Column matrix. So a column matrix is a matrix that has only one column, or is a matrix of order of n by 1. So that is what we call column matrix. A column matrix is a type of matrix that has only one column or order of m by 1. E.g., so if you have this 2 or A11, A21, A31. So here we have a row 1, row 2, row 3, but the column is only one column. So the order of this matrix will be 3 by 1. So you can also have a m in the sense that your m determines the number of matrix you have here. If it is 3, so 3 by 1. So we are considering just 1. The 1 stands for the number, that is, it has only one column. That is why we call it a column matrix. Another thing we are going to consider is a square matrix. We want to look at a square matrix. Square matrix. Square matrix. A square matrix is a type of matrix whose number of rows and columns are equal. So here, when you count the number of rows and count the number of columns, so the two numbers are equal, we call it a square matrix. That is, the order is, they have the same order, maybe 1 by 1 matrix, 2 by 1, or 2 by 2, 3 by 3, 4 by 4, 5 by 5. So this number of rows is also the number of columns. So that type of matrix is called square matrix. For example, if you have let's say A11, A12, A21, A22. So this matrix has the number of rows to be 2. So this is 2 by 2 matrix. If you have this as well, 4. This is 1 row and 1 column. We call this 1 by 1. So other examples, you may have 4 by 4. You may have 5 by 5. So when you consider the rows and the column, they have equal number. We call it a square matrix. Another matrix we are still going to consider is a diagonal matrix. Diagonal matrix. So as the names imply, diagonal. So we know that in a rectangle, if you have a rectangular shape like this, so this edge and this edge, when you join the two, this is our diagonal. Or if you are considering this edge, this is also diagonal. So we have two diagonals in a rectangle. So also in a matrix, a diagonal matrix is a type of matrix in which the upper and lower elements of the diagonals are 0. We call it a diagonal matrix. So a diagonal matrix has its upper and lower diagonal elements equal 0. So what are we saying here? For example, meanwhile, it must be a square matrix. It must be a square matrix. That is 2 by 2, 3 by 3, like that. So let's say you have a 4, 0, 0, 2. So this is our diagonal. This is our diagonal. So this is our diagonal. This is the diagonal element. This is our, we call this one main diagonal. Main diagonal. So you may also have the one of this. If it is 3 by 3, so 4, 0, 0, so 0, 2, 0, 0, 0, 1. So like this, we have our diagonal here. So we discovered that the upper and the lower part of this diagonal, the element are 0. So this type of matrix is called diagonal matrix. So we may also have an anti-diagonal. Anti-diagonal in the sense that if the diagonal is from the left, the right top to the bottom. But if it's from the number or the number of elements is from the left top to the bottom, so we call it a main diagonal. So this is anti-diagonal. So anti-diagonal. So when you have this, we have a 0, 0, 3. Then we have 2, 0, 0, 5, 0, 0. So like this. So this is our diagonal matrix. the diagonal elements. So this type of matrix is anti-diagonal. So this one is anti-diagonal, and this one is the main diagonal. See, when it is like this, it is a main diagonal, and when it is like this, it's a anti-diagonal. So those are the definitions you want to look at, or the types of matrices you want to consider here. So we are moving to the last one, which is operations in matrix. So when we say operation, we mean addition, subtraction, and multiplication of a matrix. So operations of matrix. Operations of matrices. So here we are considering the addition, we are considering the subtraction, and the multiplication. So we can also consider the division. So let's look at this three. So addition, subtraction, and multiplication of a matrix. So how do we add or subtract a matrix? Addition and subtraction of a matrix. So two or more matrices can be added or subtracted, provided they have the same order. That is, if you are adding two matrices, of which first one is 2 by 2 matrix, or order of 2 by 2, and the second one is order of 2 by 2, you can easily add or subtract. But in a situation whereby they are not of the same order, we cannot add or subtract. So that is the law of addition and subtraction of a matrix. So when they are in the same order, we can add or subtract. For example, if you have a matrix A of order of, let's say, 2 by 2, and the matrix B, we have it's also 2 by 2. So these two matrices, they are of the same order. We can easily add or subtract the two. So our AB, that is A plus B. This is A and this is B. So we can easily add this and this. We have a 2, 2, 3, 4 plus 3, 2, 5, 3. So these two matrices now we can add. And how do we do that? It's very simple. This element here is corresponded to this element. So these elements that are corresponding, we just operate them. That is, 2 is equal to 3, or 2 and 3, they are in the same column. So the cell here is the same thing as the cell here. The cell here, the same thing as the cell here. 4 and 3, they are in the same cell. So we can easily say 2 plus 3, then 2 plus 2, then 3 plus 5, and 4 plus 3. So we can get our final answer. So this plus this one will be 5. So this one will be 4, and this one will be 8. This one will be 7. So that is the addition of these two matrices. So let's look at the subtraction. See, the same way we can also subtract when they are of the same order. So when they are of the same order, we can also subtract. So our A minus B will be equal to, so don't forget we have 2, 2, 3, 4. That's our A. 2, 2, 3, 4. Then minus our B. Our B is 3, 2, 5, 3. 3, 2, 5, 3. So we can also subtract. So this will give us 2 minus 3. Then 2 minus 2. Then 3 minus 5. 4 minus 3. And this will give us our final answer. So 2 minus this will be minus 1. Then this will be 0. This will be minus 2. And this will be 1. That is our A minus B. So that is how to subtract any given matrix. So if it is order of 3 by 3, you see the same thing. 4 by 4, you see the same thing. So the next thing we want to look at is multiplication of a matrix. How do we multiply matrix? So the problem here is not the same thing as that of addition and subtraction. So we are solving it in different categories. We are not considering the same elements of the two or more than the matrices given. But what do we do here? We are going to apply a little operation here. And let's say you have a matrix A is equal to 2, 4, and you have matrix B equal to 5, 3. So you have matrix, let's say you have a matrix, we have 2, 4, and matrix B is 3, 5. So like this type of matrix, if you are multiplying A and B, that is the scalar product of it and the vector product of it, you are taking the row to multiply the column. The row multiply the column. So that is how we operate this. So if you want to find the vector product of this, A times B, which is AB, is equal to 2, 4 times 3, 5. So the rule is the number of rows must be equal to number of columns of any matrix you are multiplying. If you consider matrix A has 1 row and matrix B has 1 column. So they must have equal row and column and equal elements. So if you consider the rows, here is 3 rows and the columns here is 2 rows and 2 columns. So, and it's also 1 row and 1 column. So those are the laws. A situation whereby this one is 3, that is 1 row, 2 row, 3 row, and this one is 2. There's no way you can multiply the two matrices. So they must have equal rows and column before you can multiply. So how do we multiply? We just take this to multiply this, and we take this to multiply this. So multiply this, multiply this. We now add the two answer. So it will be this times this plus this times this. So we are going to have a 2 times 3 plus 4 times 5. So this one will give you 6 plus 20. So the answer will be what? 26. So that is the answer. So you are multiplying the row by the column. Let's consider the one of order of 2 matrix, 2 by 2. So let's consider order of 2 by 2. Example. Given that matrix A or matrix P is equal to 2, 4, 3, 1, and matrix Q is 1, 0, 4, 3. Find the matrix P and Q. So we are multiplying P and Q. So how do we do this? Our P times Q will be equal to, this is our P, 2, 4, 3, 1. And our Q times our Q, 1, 0, 4, 3. So we are considering this is the first row. We used to multiply the first column here, just like this we did. So this multiply by this. So this times this plus this times this. So likewise, the same manner, we are using the elements here. We are using this to multiply this, plus this to multiply this. So it's going to be this times this plus this times this. So the answer we got there will be our first element, just as we got this. We are going to get single element there. So we open another, it will be 2 times 1 plus 4 times 4. So when we add this, that will be our first element. So the same thing, we used to multiply this. So we are going to use it to multiply this as well. That is, this. We've used this to multiply this. We'll use this again to multiply this. So that will be our second element here. So it's going to be 2 times 0 plus 4 times 3. 4 times 3. So that will be the element here. So the next one now, we are done with this first row. We now take the second row. So we are using this second row to multiply the first column here, at the same time to multiply the second column here. So it's going to be 3 times the first element here is 1 plus 1 times 4. So this times this. This is the answer. And we are going to take it again to multiply this. So it's going to be 3 times 0 plus 1 times 3. So it's going to be 3 times 0 plus 1 times 3. So the next thing is to simplify. So this will be 2 plus 16 and this will be 0 plus 12. This will be 3 plus 4. This will be 0 plus 3. So when you add the final answer, which is equal to PQ, will be 18. This plus this will give you 7. This plus this will give you 12. This plus this will give you 3. So this is the multiplication form of this matrix P and Q. So thank you very much. Next time we are going to solve more questions on this matrix. Don't forget to subscribe so that you get the more videos when we drop it. You can also follow us on TikTok or Telegram or Instagram. We are there. Thank you very much.